Dear students, in this lecture we are going to discuss phasor diagram of a three-phase alternator. Based on two reaction theory studied in previous lecture, we have two components of armature current as ID and IQ, where ID is component of armature current IA along D axis, and this phasor IQ is component of armature current IA along Q axis. And the drops due to armature reaction and leakage reactance along D axis and Q axis may be written as J IDXD and J IQXQ along D axis and Q axis respectively. This contains total drop due to armature reaction and leakage reactance. Remember, the hypothetical reactance is XAD and XAQ. When we are going to combine the leakage reactance with this, so we may write direct axis synchronous reactance and direct axis synchronous reactance along Q axis, along D axis, like this. That's why when we are going to multiply this with ID phasor, component of armature current IA along D axis, so this drop gives the drop corresponding to armature reaction as well as leakage reactance along D axis, and similarly this along Q axis. Now the per phase induced EMF, that is internal induced EMF, excitation EMF, may be written as per phase stator terminal voltage Vt, or simply write V, plus some drops. These drops are along armature winding due to armature resistance IA RA. So we may write IA RA, or better write in terms of components ID RA plus IQ RA, that is IA RA drop. These two phasors are together with IA, so this is nothing but IA RA drop. Fine. Plus these drops due to armature reaction and leakage reactance along D axis and Q axis. So you may write, okay, just write here, I am writing here, plus JIDXD plus J IQ XQ. So one by one we will draw phasor diagrams for various power factors. So let us take first lagging power factor. Lagging power factor case. So obviously for salient pole, then we will draw for cylindrical. So for salient pole we have equation in front of us, because for non-salient pole, that is cylindrical, these two are equal. So together we may write XD is equal to XQ is equal to XS, right. So as usual, let us take reference as V phasor, then draw Q axis at an angle of delta, where delta is power angle or load angle. So delta is required to be known here. If not known, that we have alternative also, we will discuss later. So assume that delta is known. So once you have drawn reference phasor, that is V here, we have selected V as reference phasor. So this will be Q axis. Just write Q axis. Once Q axis is known, then perpendicular to this will be D axis. So perpendicular to this just write d axis. Fine. Here also you can extend this way or this way, right? D axis, q axis, then again d axis, q axis, and like that. Now we are considering lagging power factor. So lagging power factor means current phasor is lagging the voltage phasor by an angle. Let us represent this I. This is I, A, lagging by some power factor angle theta. So let us have two components of this IA, these two components ID and IQ along d axis and q axis, like this. So this will be its component ID and this will be its component IQ. This will be its component IQ. Fine. We have taken this projection along d axis, that is ID, assume it perpendicular, this is 90 degree. So projection along q axis IQ, component of IA and IQ. Now we are going to draw this ID RA drop. So RA is a scalar quantity. So this drop will be along ID and ID is along this. So from in V we are going to add this drop. It means along this we will add this. This is, you may write ID RA. Now add this IQ RA. So RA is a scalar quantity. So this drop will be along this phasor IQ and IQ is along this. So IQ RA will be, fine, or you may write IA RA along this. Assume it parallel to this. So this will be IA RA. You may write IA RA. IA RA is nothing but ID RA plus this is IQ RA. Fine. The same thing. Either you are going to directly add IA RA, that will be in parallel with IA obviously, or the two components of IAR, ID and IQ. So ID RA along ID and IQ RA along IQ. So these two phasor must be giving the resultant as IARA, like this. Now in this phasor we have added this and this. Now next we have to add this. What is this? J times ID XD. So J operator rotates this phasor by 90 degree in anti-clockwise direction. We know it very well. So if this is ID, so J ID will be perpendicular to this, right? So perpendicular to this will be along this. So just write here perpendicular to this. If you will extend, it will cut here by 90 degree. So what is this? JID ID XD. Fine. So we have drawn this JID XD. Now next will be JIQ XQ. So IQ is this way. So 90 degree rotation will give this, means parallel to D axis. So from here just extend this. Okay. Better to extend this. This is J times IQ XQ. So this, the sum of all these phasors gives E. We know that EMF E is induced along Q axis, right? we discussed in previous lecture. So this is our per phase induced EMF or no load EMF E. So this way we have drawn the phasor diagram of a salient pole. We have written this direct axis and quadrature axis components for salient pole. For cylindrical, these two phasors as discussed are same, means values are same as we have uniform air gap. What will we do when delta is not known? Power angle or load angle is not known. If delta is not known, then we have one alternate method. So write down for that or write in steps. So step number 1, I am writing here, select a suitable scale for V and also for suitable scales, but write V and current phasor. Take suitable scale, any scale you can take. It is better to write in per unit. So you